Okay, welcome everyone. So this is part two of the chapter 8 of MGTS 103. So we've already done part one where we looked at most of the notes or the slides. And what we will do in this part two is just to go over some of the questions that were left. So I will directly go to question number 27 at the end, which is where we were at the end of part one. So, okay. So here is the question. Let me just get my pen going. Okay, so the question is annual starting salaries for college graduates with degrees in business administration are generally expected to be between $30,000 and $45,000. Assume that a 95% confidence interval estimate of the population mean annual starting salary is desired. What is the planning value for the population standard deviation? How large a sample should be taken if the desired margin of error is $500, 200, 100, and then part D is would you recommend to trying to obtain the $100 margin of error? Explain. Okay, so first of all, we know that margin of error is so margin of error is given to us in different parts here, and we are required to calculate the sample size. Excuse me. So we know that the formula for calculating the sample size is n is equal to z alpha by 2 square times sigma square divided by e square. Now we are supposed to calculate the planning value. Let me just get a thicker pen here. Okay, just a moment. Yeah. So we now sigma is not given to us, but we know in one of the slides, if you look at, so in one of the previous slides, it says that if sigma is not given to us, the population standard deviation, then we can just estimate it by using this formula, maximum minus minimum divided by 4. So in this case, maximum salary is $45,000 and minimum is $30,000. So 45,000 minus 35,000 divided by 4 equals 3750. So we will use this as a planning value. Now we are told 95% confidence interval. So 1 minus alpha is 0.95. Alpha is 1 minus 0.95 equals 0.05. So alpha by 2 is 0.025. And what we have seen before is that if this area is 0.025, then the z-score is going to be equal to 1.96. Okay, so we have everything we need, and let's calculate the desired sample size. Okay, so in part A, the desired margin of error is $500. Okay, so n is equal to z square times sigma square divided by e square. Z is 1.96, so 1.96 square times 3750 square divided by 500 square, and this comes to 216.09, and as a conservative estimate we just round up and we'll say the desired sample size is 217. Okay, so in part B, the desired margin of error is now reduced to $200, and using the same formula you should get a sample size n equals 1350.56, which we round up to 1351. And then in part C, where the desired margin of error is even lower at $100, you should get a sample size n equal to 5,400 and 2.25. So 5402.25 or 5403. Now part D is saying, would you like a margin of error of $100? And we would say no, because to reduce the margin of error to $100, we need to take a huge sample of 5403 students, you know, which is expensive. So we might just trade off and say, well, we are okay with a with a higher margin of error, which requires us to take a lower sample size. So maybe either part A or part B, right? So that will just depend on the objective of our study. Okay. Okay. So let's move to question number 32 now. Let me just open it on my slide here. Okay, so a simple random of 800 elements generates a sample proportion p bar equals zero point 0.7. Part A is provide a 90% confidence interval for population proportion. Part B is provide a 95% confidence interval for population proportion. Okay, so we know that the formula is P is equal to P bar plus minus Z alpha by 2 times P bar 1 minus P bar divided by N. So in part A, 1 minus alpha is 0.90, the confidence interval. So alpha is 1 minus 0.90 equals 0.10. Let me just improve the thickness of my pen. Okay, so alpha by 2 is 0.05. So Z alpha by 2, we've calculated several times, is 1.645. Why? Because this area is now 0.05. So this Z score is 1.645. Okay. Okay. So we have everything. So let's do part A. So P is equal to 0.70 plus minus 1.645 times the square root of 0.70 times 1 minus 0.70. Oops, sorry. Wait a second. Where did I go? Let me just go back to the previous slide here. Okay, here we are. Yeah. Divided by the sample size n, which is 800. Okay, so which when you solve comes to P is equal to 0.70 plus minus 0.0267. Okay, so this 0.0267 is your margin of error. Okay, and we can say that the 90% confidence interval is equal to 0.6733 to 0.7267. Okay, part B, you would do the same way, except now the alpha has changed, and so the Z value would change, and your answer would come to the 95% confidence interval would come to 0.70 plus minus 0.0318. Okay, so this is what you should get. Okay, so let's move on to the next slide and the next question. Okay. In a survey, just get my pen going here. In a simple random sample, sorry, let me just move on slide 30. Yeah, question number 33 now. In a survey, the planning value for the population proportion is P star is equal to 0.35. How large a sample should be taken to provide a 95% confidence interval with a margin of error of 0.05? Okay, so we know that N is equal to Z alpha by 2 square times P star times 1 minus P star divided by E square. Okay, so in this question 1 minus alpha is 0.95, so alpha is 0.05, alpha by 2 is 0.025, and so Z alpha by 2 is 1.96, right? Because if you have 0.025 area here, then the Z score should be 1.96. Okay, and then P star is given to us, so and E is given to us. So let's just calculate. So N is equal to 1.96 square times 0.35 times 1 minus 0.35 is 0.65 divided by E square is 0.05 square, which when you solve should come to 349.59, and we'll just round up to be more conservative, and we'll say we should take a sample of 350. Okay, so I believe with that we have finished the questions from the recommended questions from chapter 8, and what I would request you and suggest is that you try some of the other questions that I've listed, and then my next video is going to be on chapter 9. Okay, see you then.